Thanks. So passing over to Sylvester with the first item.
All right, hi guys. All right, so yeah, just some updates for Redis cluster cache. So we have switched over the read traffic. The write traffic has been going on for 1 week because we had to be careful around all the S1 and S2s, and we also ran the migration script twice. Like the first time is to migrate the bulk of it, and the second time was to validate the migration. So the read traffic was cut over yesterday, and this morning, which is about 10 hours ago. No, wait. Yeah, there about 8 hours ago, I've switched off the read traffic. No, the write traffic to Redis cache. So Redis cache is no longer doing any work, at least any meaningful work. So this is the 3 days. Let me just refresh it. I'll just do 2 days. So this time was when the read traffic got cut over. So you can see there's a big dip on Redis cache, and then here was when I cut over. I terminated the double write, and Redis cache just went to a very small number. So it has Redis cache still has a lot of keys that's going to terminate, and Redis is going to run it in the background to remove all of that. So I don't, yeah, so won't be surprised to see a small number. But in general, we have 5 shards running, and it was fairly stable. Stephanie and I were looking, like, keeping an eye on like all the metrics for Redis cluster cache, for Redis cache, and also web and API and WebSockets and Git. So they all looked fine yesterday, and today I'm just wrapping up some of the details. One thing that's interesting is that we have so this is network, Redis network out. So you can see that 4 or 5 of them are fairly similar, and then one of them is standing out particularly more than the rest. But this changes with time. So I suspect this is probably just a hotkey or a key with a larger payload and is being accessed more. I don't think it's particularly worrying right now because we have a lot of headroom. We have quite a bit of headroom on all the Redis.
Right.
But we do probably need to.
It's only 20% CPU
yeah. So
utilization.
at peak is like 20% on the biggest one. Wait, no, this is Redis cache. Yeah. If you look at the bottom, this little clump, they are around 20% at max. So we have time to do like a deep dive on why is that imbalance, and we probably want to have like a slightly longer data collected so we can observe if there's any pattern. Like maybe some of the keys are for some users in a particular time zone and they hit it a little bit more. We are, like there are many reasons for that. So we'll probably have to do a profile later on.
Some
But
sort of
yeah, so
that's used across like all of the instances or something like that.
Yeah, that's possible. Hold on, where am I? Here. Yeah. So that's about it. Right now, we are just gonna wait and let it like sit for like a week and just observe before we do any sort of tear down. And given like the availability concerns, it's very likely that we'll wait till August because it's already almost end of July. We'll just wait a week or two and then we'll do the tear down later. But right now it's working as expected, and I think Igor has merged it. So I've increased the severity for this from S4, which is because it wasn't really running, to the S2, which is the standard for all the Redis. So I would say it's as good as in production. Yeah.
That's awesome.
It's amazing. Like
really
amazing.
boring migration like that. This time.
Yeah. The biggest workload of all the Redises, and the migration is just like done. Like this just, and I'm speechless because it's wonderful. Like this is a really good piece of work.
Yeah, that was awesome.
Yeah, that's some interesting things is that well, I mean, cache is still quite easy per se. the next one is shared state, which is going to be is fairly tricky. And I'll probably bring up another time in another demo. But some issues are like for shared state has pubs up, and pubs up works with workhorse. So we've got workhorse like Go library dependency, things like that to work with. And what else is there? There's exclusive leads, which is like a locking kind of thing. So if you do a set NX, you can't do a double write for set NX because there will be like the second write will step on each other, and the values will be set differently. So there are these little application side intricacies that you have to iron out. But yeah, that's the plan, at least tentatively for Q3, which is to do the rest of the application. So the only thing that's non-cluster compatible is Sidekick, because Sidekick is not supposed to run that way.
Actually,
Yeah.
one thing I do want to mention on the Redis shared state that I found kind of interesting. I ran a TCP dump analysis a few days ago. Let me see if I can pull it up. So this is capturing traffic on the shared state secondary. And the reason for that is when we looked at a CPU flame graph, we saw that a lot of the CPU time is actually spent on I/O, on writes in particular. And when we compared the ingress on the replicas, basically that's an indicator of how much incoming replication traffic is happening. And you take that times 2, and then you have an approximate share of how much of the writes happening on the primary are actually targeting replicas as opposed to targeting clients. And it was like 50%. So a large chunk of the work that the shared state primary is doing is actually replication traffic. And I wanted to get a better idea of what that looks like. And so this is capturing incoming traffic on a replica and then aggregating by the size of that incoming traffic, which gives us a sense of what are the main contributors. And what was kind of surprising to me was we can actually see publish showing up here. And that was surprising to me to even see published traffic on a replica, because the way that PubSub usually works is you have clients connecting to the primary, and then some of them subscribe and some of them publish, and it sort of goes directly to the clients. But what Redis does is it always also publishes to the replication stream. And so all of the published traffic must also go to replicas. And that kind of means that it can be an optimization target. So if we reduce published payload sizes, if we shift published traffic to a different Redis, that can also reduce load, which was kind of a surprising result to me. And I just wanted to kind of show that.
Igor, one other thing, just if you share screen again for a second.
Sure.
The e-tag traffic,
Yeah.
could that not move to the caches? I'm trying to think if there's any reason why that needs to be on the persistent shared states. I don't think it. I think it could be on the caches.
I think
if we
so
use
too.
that information,
Yes.
it's because it's effectively e-tag caching, right? Or
Yeah.
it's saying, oh, we've had this response before. Like keep your
Yep.
existing.
That's a good point. Yes.
That's probably. I mean, I don't know how big that. I mean, it's pretty big compared to the next
It
thing
is.
down. That might be a little piece of work to
I
actually.
can tell you exactly how big it is.
Yeah. So that's a
26%.
big chunk of change. It might be actually worth
Yep.
migrating that to the
Yep.
cache instance.
That's a really good point. Yes.
Yeah.
What do you think, Sylvester? Just wanted to also get your thoughts on it.
Yeah, I think it's reasonable. I've always wondered why eTag caching has the word caching, but it's not in cache. So yeah, yeah. So I guess we could do that.
It might have been that there wasn't a cache instance when we built that. Or maybe the workhorse only spoke to the primary to the shared states Redis. It might have been that as well, and it was just like a easy thing to do. Traffic to
Yeah. I'm not sure about that because I've checked through workhorse Redis operations. It's mostly with key watching, which is the runner queues, the pub sub for runner queues, and also it does a get on one key, which is also runner queue related.
I don't think workhorse looks at these keys. I think it's Rails
it was
only.
the next iteration. The first iteration was that Rails would do but the whole idea was that workhorse, and maybe it has never been done, which is kind of sad, because you could short circuit that at the workhorse level, right? Like if you look, I think there was something in the original design doc about like just short circuiting that and doing the conditional response at workhorse and not even bothering with Rails. And it might have been like, oh, we'll do that in the next iteration, and 6 years later we haven't done it, which is kind of funny. But yeah, so maybe that is the case. I always think it's not happening. It happens, but it's quite likely that it's not.
Yeah, I think
someone take an action item to research that really quickly. Just confirm whether that's true or not, so we have it in the backlog. Sorry, Igor.
Sure.
It might be an easy win if it's possible still.
Yeah, it has expiry, so I guess it can be cache. Because typically when you attach a TTL to it, it's cache related.
Okay. Marco, you have the next one.
All right, I just have a little bit of sidekick SLI things to demo. Let me share my screen. All right, so for a little bit of context, in our sidekick service, we originally have this per shard SLS, so we kind of hacked because we want to monitor each shard. We originally only has things like shard catch-all SLI, shard database shortcut SLI. So this originally tracks both the queuing and the execution side of the performance. So that means whenever there's index drop, we couldn't differentiate whether it's a queuing or execution kind of issue. So what we have done for a bit here, we actually now already have a separated execution SLI index and the queuing SLI index. And the way we did this differently is that previously for our per shard SLIs, we calculate from the histogram that we scrape from the Rails application. And then the appdex calculation, whether it's a 0 or 1, happens in the recording rules aggregations. Whereas the new sidekick execution and the queuing ones will actually, the calculation happens in the Rails app itself. So it's similar to the ones we have in the Rails request. So then it becomes, all the aggregations becomes easier. And then we would, once we replace these old per shard SLS, we actually will have much less metrics because we only have just the counters instead of the histograms. Yep. So the sidekick execution was here since last week, and then today I just rolled out the new one for the queuing, which is why you can only see this amount of data. And then another thing that is worth noting is that, so usually our SLI would start with GitLab component appdex, whereas the one we have for the sharded ones, just give me a second to load here. I'll just show here, I guess. So it will have something like component shard appdex, and then we have the component equals to cyclic queuing, and then we have the labels by shard itself. Yep, so we have all these different shards within one component name. And then what I've made the changes in the dashboard itself. So instead of we have this shard template, so you can just select from the drop down. So, and then it will respect the shard template into this appdex panels. So now you see all the shards, but you can just see the related ones that we want to see. And then the saturation panels also respects this shard. So previously the saturation panel is a global view of every shard. So now we can see in a fine grainer. Yeah, so I guess the next steps is I will completely replace all this per shard SLIs. So we will just have like 2 rows of SLIs here, and then you just drop down by the shard templates on top. Yeah, that's about it.
Marco, if I understand correctly, the application's emitting like a 0, 1, potentially also like a half, depending on the threshold.
Depending on the urgency, the
Yeah.
feature. Yeah.
And is that been built in like a sort of generic way where other places that we want to measure latency can use it, or is it kind of like a once-off, just for Sidekick?
It's a one-off for Sidekick because because for like Rails requests, I guess, and Sidekick workers, they can have different urgency. So I kind of make it the one-off for Sidekick.
Yeah,
it's just a simple class.
Yeah, it's just there's been some discussion in the past, I think particularly with Bob, around kind of abstracting them out, where you can basically give you have like a yield, and you can run something in there, and then you say, you know, what the satisfactory and the tolerated thresholds are.
Right.
This is unrelated to this work. It's kind of like a semi-related. It's not, you know, I think this is really great. Like, but and then we can kind of reuse that in places where we want to record updates. But just doing that will make a huge difference to the number of metrics. And are we getting rid of the latency metrics altogether, or are those still there but just not being consumed?
Yeah, it's the next thing I'm trying to audit, whether we can kind of replace with this 0, 1 appdex or not.
Yeah.
Whether we still have important places, whether we can actually want to see the duration, or this logs is fine for us.
Yeah, the durations themselves, like especially like I know a lot of software engineers in the stage groups kind of rely on those histograms, but really like the most important thing there is to educate them in how inaccurate those histograms are. You know, they can be out by many dozens of seconds, right? But people tend to take them as like, you know, absolute truth. It's like, oh, well, look, we saved a second. And it's like, you really don't know that. And so like the thing is, if you encounter kind of pushback from stage group teams who's saying, oh, well, how are we going to know? Like, what you've got to do is kind of teach them about using Elasticsearch and the logs rather, right? Like that's kind of the way that we have to kind of help those teams. You know, for actual latency metrics, it's much better just to use Elasticsearch.
Yep, I guess I will. It's part of the epic. We also make a write up documentation about this SLI, how it works, and then what to do.
Awesome.
Yeah, it's going to be really nice being able to split it clearly between the queuing and the execution. Just provides so much more detail as to what's actually going on in there, rather than the apdex is fine. Like being able to split the 2 pieces out is great.
Just one other minor point. You know, shard detail dashboards as well, and have you updated those? So if you
They
scroll
are here.
no, no. So
Oh.
actually to the top. Sorry, and then just to the top of the, and then you'll see there's a on the right hand side. So you can go this way as well. Yeah, there's a shard detail side. It's the second last one. I mean, and then this has got the same pull down that you were showing earlier, which gives you like all the metrics for a particular.
Ah, yeah.
Yeah. So it might be worth just keeping this up to date as well. I
Right.
mean,
Yeah. Yeah.
I don't know how many people use this. This is one of the places where the histograms are used. But we can get rid of those. I don't even know if anyone uses this dashboard, to be honest. It's very slow.
I have used this dashboard during incident response for sure.
Yeah, because it's very inaccurate because it uses the histograms. It's very slow because it uses the histograms, but also like Igor says, during an incident, sometimes you need that.
Yeah, the thing with the application itself, we can't really replace that with to the actual duration.
Yeah, I mean, it's some world where we could make that query into Elasticsearch and plot it in here. Like Grafana does support Elasticsearch as a data source, but it's probably easier just to push people through to Elasticsearch and give them a graph in there.
Right. Yeah.
So I had another question as well. You showed the site, or you touched on the Sidekick saturation panel, and that's now kind of broken out by components. And it's kind of a lot of information. And so I guess for context, when I'm dealing with an incident, I usually try and kind of scan the top row of a service in order to be able to tell at a glance whether there's anything obvious that looks out of place. And with this amount of lines, it's kind of hard to gauge. So I'm just kind of wondering whether there's some sensible way to make the UX more friendly for that.
I guess the thing is, because the default is a all shot, would it be better if it's like just a catch all at first? And then because during incidents, usually it's for a shard, let's say catch all, then you would change here.
Yeah, I guess that can work. Yeah.
The other option is we sort of keep those per shard details in that shard dashboard with the pull down. But yeah.
Yeah, that's how I've usually approached it. But I guess if we're moving more towards the shard being selectable on the main dashboard, then that also works. Yeah, that's fair enough.
Yep. And another thing also, I've discussed it with Bob last week. So because now we have two SLIs, and then if we were to aggregate both execution and queuing into the service aggregation, we would then have like double RPS and double of the error ratio instead of just the one that we have per shard. So we currently don't have a way to kind of indicate whether this SLI is only for RPS or for Apdex or for the error ratio. So, whereas for queuing, we only have the Apdex based on duration, not on error, right? So yeah, this will be the next work also to kind of support this aggregation by a finer grade. That makes sense.
Yeah, just sort of like, I mean, a lot of the reason why we had that second dashboard was so that to kind of avoid the confusion, of because obviously a lot of those graphs are also like really complicated the way that the way that they're developed at the moment. So I'm just kind of worried that if we are adding in all that extra complexity about like selecting on labels and stuff, whether it would, and then obviously also if you scroll to the top, we've got the range you know, the normal range. And then obviously if you've got two, you can't really do, well, I don't know how you would do that with two values in there, for example. Or I don't know if I'm kind of missing what you were saying.
No, what I was saying is, so we have this in our metrics catalog.
Yeah.
So we would have this service aggregation field of flag. So what this flag does is it will aggregate all the AppDex error and
But you're
RPS
not talking about two
up
signal.
to the aggregated.
It's still a single aggregated value, not two in there or multiple.
Yeah, it's still single. It's still single.
Okay,
Still
sorry.
single. But then if
I got you,
yeah.
Okay.
So if I were to just include the Sidekick execution in the service aggregation, we would miss out the Sidekick queuing performance in the aggregation and all the way to the top to the SLA, I guess.
Right. We
actually want both.
We want to include AppDex, but we don't necessarily want to double up on the RPS metrics.
That is correct. That is correct.
Oh, right. Yeah. So we can't do service aggregation on a per sub attribute level. We can't do
yes.
like the AppDex, but not the RPS. That's interesting. Yeah. That shouldn't be too hard to change.
Yeah.
I mean, a lot of the RPS are like kind of a little bit out there. Like if you think about the web, you know, when you think of the RPS of web, it's like one request comes from a user, but the way that we count it on there is really like one request into Workhorse, one request into Rails. And so it's really a relative measure rather than a hard.
Right. Yeah. Yes.
You know, because we double count a lot of things in that
service. Right.
Yes, but I mean, it would be better if we could fix that and actually make those realistic.
Yeah, I mean, quite often, if I want to see how much traffic a service is actually getting, I'll go to the dashboard, I'll skip the RPS line, and I'll go down to the SLI, and then we have load balancer error, like load balancer request per second, Workhorse request per second, Rails request per second. We usually have those three, right? And then that gives a more realistic estimate.
I mean, the other way we could do it is we could say that for a service, instead of aggregating all the RPS to get the service RPS, we say RPS from this component. And so RPS is kind of different from errors and AppDex. So that you know, normally it would be the load balancer component that would give you the RPS for the service. Because it would be much more realistic than what we have at the moment. Something to think about.
Yep, I think that makes sense. Yeah, I guess that's about it from me.
Great. Well, we're at time. Thank you everyone for the demos. Much appreciated. Hope you have a good rest of your day.